Hello everybody, this is Dr. Eldek, and today we'll have experiment number 4, and it is about the breadboard. Breadboard is used to connect circuits, and we'll see how in this experiment how we connect a circuit using breadboard. As a breadboard, this is one example of it. The breadboard, you see each 5 holes are connected together. Why? Because there is a metal strip underneath. So these 5s are connected, 5 holes are connected, these 5 holes are connected, and so on. And the extension in the top and bottom, the whole line is connected, and the second line is connected. Here, for third line is connected, fourth line is connected. And these are usually used if you have, for example, power supply and 5 volt, positive 5 volt, negative 5 volt ground. Then you connect each one of them to one of these lines. Then you mainly build the circuit here in this area, and then you connect the voltages to these lines. So as you see here, the is underneath these 5 holes you have a strip. So this is what make it connected. All of them are connected. So this is the idea of the breadboard. Then how it look like in when you connect a circuit, this is how it look like. You see here, for example, you have this is a capacitor. It has 2 legs. So one is connected to this node and one is connected to this node, or this hole and this hole. Now this point is connected to this point, but this one is not connected to this one. Why? Because they are in a different sets. So for example here, this leg is connected to this yellow wire, and this yellow wire is connected to this leg of this chip, and this yellow wire is connected to the other side here, and then it is connected to this resistor, and so on. For example, this lead is connected here to this. It's connected to the capacitor and the black wire, and the other side is connected here, and so on. So this is the idea of the breadboard. Let us see some examples. If I want to connect, for example, this circuit here, we have 3 resistors in parallel. So how do I connect them? For example, assume that I connect this resistor here between these 2 nodes. So it's here and here, between this point and this point. Then you connect another one, for example, like this. And then you connect another one, like this. Now we have this 3 components, 1, 2, 3, or 3 resistors, for example. Then next we need to connect wires. So we have the wire between this point here, okay, and the other point is here, this one. It's here. So now this will make the 2 resistors connected. Why? Because you have one of them is connected to this one, and the other one is connected to this one. Okay. What if we have we need to connect these 2, for example? In this case, we need to connect them like this. Now let's see this one, if this will make it a little bit. Here it is, for example. Yes. Now it's more clear. Okay, so now we connect this 3 resistors. Sorry, this one is supposed to be connected like this. There it is. Okay, now the 3 resistors are connected from the top. If we want to connect them from the bottom, we can do the same. Okay, so now these 2 are connected, and these 2 are connected, then the 3 are connected. Then if I want to connect them to, for example, A and B and C and D, for example, then you just need to connect them like this. Then this will be A, and the other one here will be B. This will be B. This is just wires. So here, this is A, this point A, and this point B. And if you want to connect them to C and D, for example, C is here. So this is C, and D will be here. Now this is D. This will be D. C, D, A, B, and so on. Okay. And if you have, for example, number of resistors in, or number of components in series, like here, 1, 2, 3 until 6, they are all in series. Then in this case, you will have, for example, a resistor like this. It's connected here. Okay. So it's connected between this node and this node. Then you will have another one connected between two nodes, for example, here. And if I flip it, it will be more clear. Here it is. Now these two resistors are connected in series. Why? Because they are connected here at this point. And then you can connect the third one like this. And now you have the three are connected together. And you can do the same for the resistors in the bottom. Let us move them here a bit better. And do the same for the resistors in the bottom. Okay, like this. So now these resistors are also connected in series. Okay? And now, if I want to connect, for example, you can make this. If I want to connect these points, this one and this one here, connect them. Like here, you just need to have a wire. For example, like this. You have a wire from here to here to here. From here to here, for example. Then you need a jumper like this. It has two. There it is. Okay. So now all resistors are connected in series. And then you have this point is A. And this point is B. Now these two here are A and B. Okay. And then if you want to see, for example, where is C and D, for example, if you want to connect something to C and D, D will be here somewhere. Any of this 3 points, 3 remaining, 1, 2, 3. So for example, this one here. So this will be D. Where's the other D? Has the other one C, for example, C will be here, for example. Okay, so these 2 points will be C and D, C and D. So this is how the circuit look like. So now you see here, the 3 points here are connected. 3 points here are connected. These two are connected. These two are connected. These two are connected, and so on. If we want to do same, for example, in the next slide here, let us change this to make it bigger. Okay. Example. Okay, so now, for example, if I have all these components, then I have this resistor like this. This is number 1, for example. Then I have number 2 here. I'm gonna flip it, that's fine. Just to look nice. So you just need to connect them to the same set of 5 holes. There it is. So you have these two are connected. And then you have this one here. Okay. And then you do the same in the other side. Okay. Just flip them like this. And now I have this 2. Okay. Okay. Then I have now 1, 2, 3, 4, 5, 6 are all connected. Okay. Then I need 7, 8, and 9. So for example, where's 7, 8, and 9? You can add 7 like this. Where it is? Can I connect it here, for example? Can I connect it like this? I don't think so, because it is not connected. You have to connect it to this area here, like this point, this point, this point, this point, and so on. Then we have to connect it like this, for example. This now, this 7 is connected here. These 2 are connected. What about the other one, the other side? Let's flip them. So again, you cannot connect it here, for example. You must connect it between, for example, 2 points here. Now these 3 are all connected together. These 3 are all connected together, and these 3 are all connected together. Okay, so these 3 are all connected together, and these 3 are all connected together. These 3 are all connected together, and these 3 are all connected together. Then you need to connect number 9. Sorry, number 9. Number 9. So here, let's connect it. For example, here, as you see here, it's connected because you are connecting them to the same set. And same in the other side. They are also connected. They're also connected. Then once you do that, now you are ready. The circuit is ready. Then what you need to do is to connect A and B and C and D. So A will be here, here, or could be here, here, could be here, and so on. And B will be here, or here, or here, or here. You have a lot of choices here. So this is A and B. What about C and D? C is supposed to be here, or here. Okay, so you can connect it anywhere as you like. This is C. And D is in the other side. Could be here, could be here, and so on. So once you do that, we're done now. So the circuit is connected. Of course, you can adjust it as you like in the real circuit. Okay, but this is how you convert a schematic or a circuit to the real circuit on the breadboard. So this will end this experiment. Next is the exercise. Let us follow the steps in the exercise. So in the exercise, what we need to do is to do what here is, let us see. So first we need to calculate the total resistance. Okay, you need to calculate it. So you have to merge them. For example, these 2 are in series, and then they are in parallel with 10 kilo ohm, and so on, step by step. So do calculation to find the exact value for the resistance between X and Y. Then find the resistance in analog, the resistors in analog parts kit. So try to find these resistors: 4.7, 2.2, 10 kilo ohm, 6.8, and we did that in the previous experiment. We did all these resistors. We found them before in the previous experiments. And then after that, which is experiment 3. Then after that, you connect them. When you connect them, you see how it look like here. This is what you need to do exactly the same. So the 2.2K, you connected between this node and that node, this node and that node. Okay. And then the 6.8, you connected to this one. Then you can connect it here or here. So you can connect it between this node and this node, the 6.8. And you have the 2.2K. 2.2K is connected here between this node and this node. Then you have the 4.7K is you connected to the 2.2. So here it is. It's connected here between these two nodes, this node, and any node here, like this node, for example, or this node. And then you have a wire. This wire is connected underneath here, but let us leave it right now. And then connect the 10K. The 10K is connected to the 2.2 and 6.8. So here it is, here in this area, this set. So here you have the 6.8. Here you have the 2.2. Then you have 3 holes remaining. You connect the 10K to any one of them. And then the other side, you connect it to anywhere as you like. For the 7.8, you don't have 7.8, so you have to make it up. 7.8 is 6.8 in series with 1 kilo ohm. 6.8 plus 1 is 7. Okay, so in this case, you connect the 7.8 to the 6.8 first to this node here, which is this one. It has 6.8 and 2.2. Then you connect the first resistor, which is 6.8, to any of these remaining 3. 1, 2, 3. So here it is. It's connected, and you connect it like this, for example. Here it is. And you connect it in series with 1 kilo ohm. Then you connect the 1 kilo ohm to any of these nodes here. So here it is. The 1 kilo ohm is connected between this node and this node. Then this will make 7.8 kilo ohm. Now you just need to connect the wires. If I want to connect 4.7 to 10 kilo ohm, as in 10 kilo ohm to 7.8, 7.8 to Y, then here it is. From 4.7, you connect it to the 10 kilo ohm. This is just wire, any wire. And the 10 kilo ohm, you have another wire connected between this node and this node here. This is the one that has the 1K. And then you have another wire, this wire, connected between this node and the input node. Now you have these 2 points here are the input of this this circuit. Then what you need to do is just connect these 2 points to the multimeter and set it to ohm. And let's see how it looks like. I connected it already. Okay, so this is how it looks like. So this is the 2.2, 6.8, 2.2, 4.7, 10 kilo ohm, and 6.8 parallel series with 1. And you have 3 wires here. Now I will connect the multimeter between these 2 points and see how it looks like. Okay, now let's see. If you have the result like this means that it is open. So the connection is not right. Okay, there's some open circuit in the middle. So you have to make sure that you have all the connections, everything is connected right. Or sometimes you may have a bad resistor, for example. Okay, so the problem, the circuit is okay, but I do not connect the second probe. So let us see the reading. For some reason it is mirrored, I'm sorry for that, but it's 6.67, 6.67. So this is the total resistance. This is the total resistance here, 6.67 kilo ohm. Thank you very much for watching, and see you in the next experiment.